This week, we're going to take the work that children have done with representations and part-whole relations and extend it further to fluency. The fluency work is directly related and follows from the work that children have already done with representations and part-whole relations. For example, last year I worked with a group of teachers on developing number talks for decomposing numbers, and we expressly worked on numbers up through 5. But by mid-year, one of the teachers reported to me that that was actually no longer a challenge for the students, that the students understood 5 in all of its fiveness, in all of its combinations fluidly, and that if she said, show me 5 a different way, show me 5 yet a different way, that they could fluidly move through different representations, 5 on one hand, 2 on one hand, and 3 on the other, 1 and 4, back and forth. At this point in time, you might say that they have a fluency for the number 5 and for working within 5, and that can translate, when it's robust enough, into recognizing that if you have 5 somethings and you can see 2 of them, that the 3 must be the other part. In other words, they have a sense of the full relationship between these 3 whole numbers, 2, 3, and 5, 1, 4, and 5, in all of the combinations of its fiveness. So at that point in time, you can say that they understand how to add and subtract within 5. Mind you, at the kindergarten level, they could still be having issues with what this looks like as written equations, because that's the symbolic language of math, and so that follows from the work that they first understand and then learn to represent. So that's part of that representation developmental pathway. We clearly want them to get to that direction. But even if a child is not yet fluent with the symbolic language of mathematics, they can still be fluent with the relationships, which is what we're talking about here. So I mentioned a moment ago that in this situation, the children were representing number on their fingers with finger patterns. So let's talk about that for just a moment before we go into the main topic. Is that kosher? Because in the past, there have been some perceptions that perhaps we're not doing children any favors by allowing them to use fingers, and that maybe that should be discouraged. Well, in fact, the progressions, which is written by the Common Core math writing team, has indicated that kindergarten teachers do not have to be concerned about children using fingers, and it shouldn't be discouraged. It's not a concern unless children fail to progress into level 2 and 3 standards down the road, and there's no research evidence to indicate that using fingers when children are young prevents them from developing level 2 and level 3. The thing that prevents them from progressing is a lack of understanding the relationships while they're at level 1. In this case, you could make an argument that fingers are a good thing because of the fact that the fingers, working with the finger patterns, helps you understand the number. And if you understand the numbers, you're more likely to develop more advanced strategies. So fingers are not a problem. You don't have to worry about the work that children do with their fingers. And it does have one huge advantage, which is wherever the child is, their fingers are with them. So it's not like snap cubes or some of the other manipulatives where they may not have them with them. They always have fingers. So if they learn how to use those well as a tool, that could be advantageous. In fact, the Common Core authors not only say it's not a problem if children use fingers in kindergarten, they do expressly say in the progressions that they want kindergarten children to recognize rapidly the visual and kinesthetic. So if you say, show me 3, everybody can show 3 on their fingers, just instantaneously without much forethought, for all of these familiar finger patterns up through 5. Now, if you have a very diverse classroom, it could very well be that some of the students in your classroom come from other cultures where number is represented differently. So the typical US pattern is to put the index finger up first to represent 1, which is what you just witnessed back here in this slide. The index finger was 1. However, in some countries, putting up the thumb first is 1. And so you see that as being the A pattern here, where 1 is thumb out, and 2 is where the thumb and the index finger are out. B is the familiar pattern you see in the US, and C is where the pinky finger goes out first. And there's even some other variations that you see with D and E. Now, that is not a problem. In fact, there are some advantages that the Common Core authors articulate towards having a range of methods, because it can get students to think more clearly about how does this represent this number? Why could you make an argument that that would represent that number too? So children can choose. They do need to have a sort of a dominant, and it's okay for them to, in fact, encouraged for them to talk with other people about how other systems might look different. But they need to have a system that works really well for them, that they can develop a type of fluidity with which they're representing number using their fingers. Those visual patterns help them think about numbers in a chunk. So for example, if they see all 5 fingers up on one hand, they get to the point where they don't have to say 1, 2, 3, 4, 5. They see it and it's a 5. And that's the advantage of the finger patterns, is that they're so familiar that when they see that pattern, they know it instantly as a group that represents this quantity. And that leads into something called conceptual subitizing, highly recommended by the progressions in the progressions document written by the Common Core writing team. And that is discussed in the Part A module. If you haven't taken that yet, you might consider doing that. All right, let's go ahead and really focus now on some of the fluency expectations, and we'll take a look at a research-based developmental teaching learning pathway for developing the fluency. First of all, I want to just look at everything it says that children need to be able to know and do within 5, because fluency is really sort of a culminating expectation. We don't plunge into it. We do a lot of work with 5, and the work that we do leads to fluency. That there can be additional practice work as well, but we don't begin the practice until we've done the tough job of understanding. So children need to be able to represent the quantities of 5 using a variety of means. 5 as a dice pattern, 5 as a domino pattern, 5 as a finger pattern, 5 as with a 5 frame. So recognizing all the quantities up through 5, within 5, in a variety of ways. Also, solving the 4 designated problem types. So there was the add to, result unknown, the put together, total unknown, and then those were the 2 additive in nature, and then there was also the take from, result unknown, typical subtraction takeaway situation, and the take apart, where the total, both add-ins were unknown, where it's essentially a decomposing number. So for all 4 of those, children need to be able to do that within 5. They actually need to be able to do it within 10, but for sure 5. They need to be able to decompose numbers less than or equal to 10, but absolutely up through 5. And so they've been doing a lot of work, or should have been doing a lot of work on these, starting at the beginning of the year with smaller numbers and leading up to the larger numbers. So now, towards the last part of the year, we want to make sure that that understanding of all numbers up through 5 is so solid that they can fluently add and subtract. That's not talking symbolic, it's talking conceptually, with an effort to then take that conceptual understanding further in representing it as an equation. But at no point are we talking about giving kindergarten children timed tests with symbols alone. Okay, so what is meant by fluency here? Well, fluency is often defined as accuracy, efficiency, and flexibility. And the flexibility is one that I'm unpacking a little bit, because the accurate and efficient elements of fluency are a little better known. The flexibility component refers to students' abilities to make decisions with that knowledge. And to make decisions about how you're going to use your knowledge requires you to have a conceptual basis. To give you a little foresight, you really have to understand where kindergarten children will be in 1st grade in order to understand how strongly they need to know it. So in kindergarten, children are really building number relationships, and they'll continue to do that over the next couple of years. But starting in 1st grade, they will be expected to have those relationships so solid that they can use what they know to figure out what they don't know. Now, if you just learn something by rote, let's say 2 plus 3 equals 5, and all you know that is by rote, it really doesn't help you solve 3 plus 3. But if you understand the relationships between 2 and 3, between 2 plus 3 and 3 plus 3, and if you understand all the relationships, you can say, well, 2 plus 3 is 5. I know that really well, so 3 plus 3 must be 6. And that's a fairly simple example. There are a number of harder facts than 3 plus 3 that can be constructed by learners in this way. Starting in 1st grade, they're going to be expected to do that. So in kindergarten, it isn't enough for them to just know that when they see this numeral and that numeral and a plus sign between it means this. They really have to understand those relationships so that they can be used flexibly as well as knowing them accurately and efficiently. Now, in order for children to develop that flexibility, in order for kindergarten children, that is, to be able to have that level of understanding, they're really going to need to still have visual representations, concrete experiences, and/or contextual situations. Why? Because kindergarten children, to them, the symbolic language of math is like a second language. They can't think in that second language yet. If you ever took a year of Spanish, at the end of that year, my guess is you weren't thinking in Spanish yet. You still thought in English and then translated it over. Well, that's a little bit where kindergarten children are in terms of the symbolic language of math. Their first language in math is visual and concrete and understanding these contextual situations that are mathematical. Their second language is the symbolic. So to develop fluency, they're going to need to be able to really get those visuals down pat before they get to the point where they can translate it over into the symbols. So we're going to use visual representations as a precursor to the equations. We're going to have some familiar realistic context situations that children intuitively understand the situation, and we're going to give them many varied experiences. So we'll keep coming at these numbers from many different ways. So instead of like time tests that pretty much look exactly the same every time you take it, except the numbers have been scrambled, so different combinations are in different orders, here we're going to come at the number from many, many ways of how to represent it so that it is more likely to be solidified as a relationship that is understood. So now we're going to take a look at a teaching learning progression, keeping all of these ideas in mind. When we work with a new number, we begin with situational descriptions, concrete visual tools, exactly what I just described. We are solidifying children's first language here for that number. And then we're going to shift and we're going to figure out how students are engaging with this task and building the schema. And when we think they're ready, we're going to move into recording. And initially the teacher records and they model how to record the combinations that children find. So if children are decomposing the number 4, then we will record the different decompositions that they found, and we will record them visually and symbolically using expressions first, which is like 2 plus 3. Once we do that, children are in a better position to discuss patterns. We're going to take a look at each of these steps in a minute, and that will become more obvious. Then the children learn to record the decompositions for themselves. They've seen us modeling, and initially they can record visually, then they can do visuals with expressions, and then eventually visuals with equations. And when they've had that basis of understanding, we can then move into unknown partner games. And the unknown partner games essentially are subtractive in nature, so that helps build the relationship that's on the subtractive end. It's a missing add-end problem, in other words. Okay, so we're going to go through each of those, starting with situational descriptions. Here's just a little funny activity, and you can use any activity. This is one I kind of made up on the spot just to illustrate how you can take just about any kind of an experience and turn it into this. I don't know if you know the nursery rhyme about Wibbleton and Wobbleton. It's basically goes from Wibbleton to Wobbleton is 15 miles. From Wobbleton to Wibbleton is 15 miles. From Wibbleton to Wobbleton, from Wobbleton to Wibbleton, from Wibbleton to Wobbleton is 15 miles. Okay, that's a little nursery rhyme that's just kind of fun. All right, so I'm going to tell a little story about some rabbits, and they get to these signs and they have to decide if they're going to Wibbleton or Wobbleton. So there's 4 rabbits. How many could go to Wibbleton and how many could go to Wobbleton? So here it's a decomposing problem. All 4 of them could go to Wibbleton, and then none of the rabbits would go to Wobbleton. Or 2 could go to Wibbleton and 2 could go to Wobbleton, so on and so forth. So the children use their 2 hands as the Wibbleton and Wobbleton hands, and they show the number 4, but they show how many rabbits are going in each direction. So we just begin by verbal. We're not going to state necessarily, if I write it down, I might write it down as 2 2 to Wibbleton, 2 to Wobbleton, or something like that. So I can record it, but more as a situation rather than going into symbolic right away. So initially, when we're just beginning to work with a particular number, we do these situational descriptions. And the children, as I said, generate the combinations, and I record them down, similar to what you've seen here. Step 2 is that they have still a situation. So the situation here is I have 5 blocks. Some are red and some are blue. How many red and how many blue blocks could I have? Again, we have a decomposing situation. And the children come up with the decompositions, the different ways to decompose 5. I'm going to represent them on the board, and I'm doing that visually, as you see here, with partitioned groups, and then also with the expression. And at this point, I'm also going to make sure that the children are making the connection between the symbolic and the visual. So I can say, what does this 1 represent? And they should be able to use the visual to say, you have 1 red block. What does the 4 represent? You have 4 blue blocks. So we're keeping them grounded in the context so that those numerals are not too abstract. They can connect them to a context. Now, the second part of step 2 is that the children are invited to search for patterns. And in this particular case, you can see that the equation illustrates an interesting pattern that isn't as obvious in the visual pattern. And that is there's a 1 plus 4 and a 4 plus 1. Now the visual pattern looks different. 4 blue in one and 4 red in the other, but the numerals show that they can be added in either order. So that's a good point to discuss with students, then also 2 plus 3 and 3 plus 2. So an activity like this can help children begin to grapple with the concept that is the commutative property. We don't introduce that term yet, but the concept. On the aspect of vocabulary, the 1 and the 4, the 2 and the 3 are addends. And we continue to refer to them that way even when we do subtraction problems. In the Common Core Progressions documents, the authors indicate that using terms like minuend and subtrahend is not appropriate for kindergarten or first grade children and could actually be a bit harmful for their understanding. And there are real advantages to calling them addends at this point because we want the children to understand the relationship between addition and subtraction. So by maintaining this language of addends and the total, we're going to help solidify how addition and subtraction are related to one another. Okay, step 3 now, the children are going to start to take over some responsibility. Initially, they can record their decompositions through visual means, so I can give them number bonds and they can record their what they discovered for decomposition using a number bond. They can do that through these actual circles or dots or some kind of an icon that's in the part whole number bond. They could put numerals. Some students might be ready for numerals while other students are still using the visual. That's perfectly okay. Then we're going to want children to be able to use a visual with an expression, which we will have modeled for a while before they have to do that. So that's the next step. And eventually we'll want children to be able to use a visual to generate an equation similar to what you've seen in the 3rd step here. So that the child is provided a visual, but then they have to generate the equation on their own from that visual. And finally, when children get to the point where they can do that, we can move into unknown partner games. I find that the unknown partner games are pretty difficult for kindergarten children without some pregame preparation, and they will continue to be difficult for some learners. But a pregame preparation means that children sort of explore the number before they go right into the game. So you have a target number and you tell them, play with these counters that have that, how many do you have all together, and what are some different ways that you can put them into 2 piles, and what are those different combinations you find out. So they work with a partner to just kind of get their mind brainstorming about this. And this is to allow them to remember what schema they actually have about how to pull a number apart and put it together right before they go into the game. Okay, so then we know the total. In the picture, the total is 6. And we're going to try to find a missing addend. So one child covers their eyes and the other child hides some of them under a cup. And then they actually can see one part but not the other, and they have to figure out what the other part is. Another way to do this is through part-whole cards, where you see a total and you also see one part, in this case the 3 orange dots, and you have to generate the other one. Another game they can play is called hide and peek, where they take a tower of snap cubes that has the target number of snap cubes, put it behind their back, break it into 2 parts, 2 add-ins, and then they let the other partner peek at one hand. Here's another one, and this one is a quick warm-up for unknown partner. They should have some experiences already with the unknown partner games, but to keep this alive in the classroom, some very quick warm-ups that can be done even when kids are standing in line and you have like 30 seconds to do something to keep them occupied works then. And it's called Finish My Set. And so for a target number that you're working with, that the class is really focused on, you have your target number for that week. And so you can show one part and they have to show the other part that would add up to that. So as the example that I have here, the target number is 5, I show 4, they have to show 1. And so those are some different, and that is so quick. You can do many of them in a 15 to 30 second interval of time in the class. You can do several in a row very fast. Because they are kindergarten, though, do remember how important context and visual is, especially for them to make sense, which they have to be able to make sense in order to do the kind of strategy development that is required in first grade. And so we really want them to actually make connections between the visual or context or concrete and the symbolic expressions and equations. So we want them to build connections in between those two. How are they similar? Also, don't rush through the numbers. The goal isn't who can be the first classroom to get to 10. You actually really want to build a solid foundation. So there is an argument for moving slower rather than faster. Remember that they need to have a very strong understanding of all the numbers, and particularly up through 5, which needs to be so well understood that they have a type of fluency where they just know that 2 and 3 make 5, and 4 and 1, and 1 and 4, and eventually 5 and 0. They know that as well for 4, 3, 2, 1. So you really want that very well understood, and then you work with the other numbers too. They should understand combinations of 10. We're going to talk about that this week. We'll talk about the 6 through 10 in the next lesson, but you don't want to just race through these like, okay, I think we've done enough with this number, let's move on. You really want them to have had an extensive work with these numbers and varied practice opportunities, and you want to be aware of who still needs more support for this number. What additional reinforcement tasks can I provide for them? What centers would most benefit them to build that strong understanding of those numbers? A manipulative that's especially useful for working with 5, and 5 is a very important number in the way that 10 is a very important number. The 5 frame is a very useful tool, and this will grow up by the end of kindergarten and into first grade as a 10 frame. But right now you can begin even very early in first semester by helping students understand numbers within a 5 frame. And so it has several advantages. You can see 5-ness, there's a visual. You can also see the decompositions because you read a 5 frame according to the dots. So the one on the top reads as 1, 2, 3, 4, and 5. But if you look at the top, I can see that I have 1 dot, but I can also see 4 is the complementary number to 1 to make 5. So I can see that I have 1 and I need 4 more to make 5. And this will really help you see those hidden partners that make up 5, and eventually that knowledge will be very useful as it goes into 10s as well. There's a variety of games that you can play to help fluently build those combinations of 5. And here are a couple of resources that are available in the Kentucky Center of Mathematics. And I have tucked into the teaching resources the information about how to access these online. Very useful tools. Also, I have a couple of games, 5 Frame Flash and 5's Alive. They're described in the teaching resources. Go Fish is easy. It's just like the regular Go Fish game, but you search for the partner number that will make 5 using these 5 frame cards, which you see part of the template for the 5 frame playing cards here. These are the resources. The Kentucky Center of Mathematics website is at the bottom, and then, like I said, it's a little hard to navigate because there's so many goodies there. So I included a document to help you find the materials you'll need for the things that I discussed in this lesson, as well as the other documents were all useful documents in terms of the conceptual basis, the developmental path